All right, we're going to do an experiment with some water, and we're going to see it travel. And we're also going to see some other cool stuff with this experiment. So what you need for this experiment is 6 cups of the same size, 3 empty, and 3 full of water, about the same amount in each one. You're going to need some paper towels, and you're going to need food coloring. You're going to need the primary colors.
Red, yellow, and blue.
That's right. Okay, so we've all decided we're going to put a color in each one. So girls, go ahead and grab your color. And
it's like they'd be like a map.
Okay. Are you gonna start adding red to yours, Emma?
Yeah.
Okay. So add a couple drops.
How many?
Start with 5. We want to make sure it has
1, 2,
enough color.
3, 4, 5. 3.
And then why don't you grab
4, 5.
Why don't you grab a spoon, Maeve and Emma? Each of you grab a spoon, and can one of you grab one for me, please? And we'll stir it to make sure they are completely. And we need, thank you. We need one for each color, so they don't mix. Okay. So just stir yours up.
It's like Jello.
Kind of is like Jello, huh? Do you think that yours has enough color in it? I think they all do. I think 5 was a good amount. Okay. So now we're gonna put our. Woo! Sorry, that was my spoon being tossed in the sink. Girls, can you go put your spoon away? And I'm going to arrange these together. So, how you do this experiment is you take a color like red, and you put an empty cup next to it. Then you put another color, yellow, and you put an empty cup next to it. Then you put another color, blue, and an empty cup next to it. So you have a circle. Now here's when our paper towels are going to come into play. We're going to take these paper towels and we're going to roll them into straws, or the best we can. So lengthwise, we're rolling them. Emma, that needs to be a little bit tighter, okay? And then I'm going to show you what I'm going to do. Sorry, my one-handed roll. So now I'm going to take this, and I've bent it in half. And I'm going to put one end in the blue and another end into the empty cup. And Maeve's going to do the same with her red one.
Oh, with that one?
From the red to the empty.
Hey, that's mine.
Oh, sorry. And then Emma, put yours in the yellow to the empty. And then we need a couple more. So that's all connected. Yep. So go ahead and roll it. See how the water's already kind of walking up the paper towels here? The paper towel's already absorbing some of the water. So now I'm going to take this one, and I'm going to take it and put it in the empty cup to the red cup.
I want to do
I'm
that.
sorry. I chose the wrong color. Now Emma, put yours.
To the blue one.
All right, so Emma, put yours in the yellow cup to the empty cup. Oh. Nice save. Okay. There we go. All right, so we're starting this at about 5 p.m. on Sunday, and we're going to check back at different hours and see how it looks. All right, here is our experiment after more than 24 hours, a whole day. So there's 24 hours in a day. It's almost 3 hours past that, so it's 27 and a half hours since we've started this experiment, and this is what it looks like. So we started with just red, and now we have some orange. We had yellow as a start, but now we also have green. You can see the green there. And we started with blue, and now we have some purple. So this experiment shows you a couple things. One, it shows you that the primary colors, red, yellow, and blue, make up secondary colors. Blue and yellow make green. Red and yellow make orange. And red and blue make purple. Maybe if we take a closer look, you can see it's kind of purpley. It's a really dark purple. Maybe if I go like that. So that's one thing it shows you, but it also tells you that it also shows you how water can go from the roots of a plant all the way to the top leaves in its the tree top. So this water can travel up by a process called capillary action. So that's what made the water travel up the paper towel. It went up and then back down. That's called capillary action. Capillary action is the ability of liquid to flow upward against gravity in narrow spaces. So like I said, that's how water gets from the roots to the top of the trees. Pretty cool experiment.